Okay, in this next video we want to go on to our second learning objective in this section, and that is we want to be able to first of all find x and y intercepts of a particular linear equation and then use those intercepts to graph the linear equation. Alright, what do we mean by intercepts first of all? Well, you should note that on a graph anything over here to the right of the y-axis, x is going to be positive, greater than 0. Anything to the left of the y-axis, x will be less than 0. It will be negative. Then, along the y-axis, it should be clear that x is always 0. So, if a graph crosses the y-axis, we can tell with certainty that its x-coordinate will be 0, because anywhere along the y-axis, x is equal to 0. Alright, so that's the first most important thing we can say about the y-intercept. When the graph crosses the y-axis, its x-coordinate is always 0. Second, what happens when a graph crosses the x-axis? Well, above the x-axis, y is positive, which means y is greater than 0. Below the x-axis, y is negative, or we say y is less than 0. Then, anywhere along the x-axis, y is going to equal 0. So we can say the same thing we did for the y-axis. Anywhere along the x-axis, y is equal to 0. And we're going to take advantage of this fact to help us graph equations, these two facts. Y-axis, x equals 0. X-axis, y equals 0. They come in opposites. Y-axis, x equals 0. X-axis, y equals 0. Okay, so these are very, very important facts here. Now I'm going to clear the board of all of this stuff, and we're going to go on and use these important ideas to graph this equation that's given here. So make sure that you have these notes copied down. If you need them, you can pause the video at this point and copy some notes down. We're also going to write right on top of this. What's important is that along the y-axis, x is 0. Along the x-axis, y is 0. So when a graph crosses the y-axis, we know that its x-coordinate has to be 0. If a graph crosses the x-axis, we know that its y-coordinate has to be 0. Okay. So how can we use that information to find the intercepts of this equation and use those intercepts to graph the equation? Well, we start with our equation, which is 3x plus 4y is equal to 12. And since along the y-axis x is equal to 0, the first thing that I'm going to do is set x equal to 0. I can do that. I can make x 0 and then find out what the y-coordinate is, and that will tell me where the graph crosses the y-axis. So when x equals 0, well, what's going to happen is that our equation, in our equation, 3 times 0 will be 0. And so that part of the equation will essentially just go away. And so we'll be left with 4y is equal to 12. And we know that 4 times 3 is 12. So y has to be 3. And we'll get the point x is 0, y is 3. And we can go and graph that. X is 0, y is 3. Next, so notice the x coordinate is 0, and when we set x equal to 0 and solve for y, it will tell us where the graph crosses the y-axis. Next, we set y equal to 0. We want to find out where the graph crosses the x-axis. So this time, y is going to be 0, and 4 times 0 is 0. And so this time, we're basically going to block out the y. The y is going to become 4 times 0 will be 0, since y is 0. And we're going to get the equation 3x equals 12. 3 times what is 12? 3 times 4 is 12. And so x is equal to 4 and y is equal to 0. So then we're going to get another point on our graph. X is 4, y is 0, and all we need to do then is to draw a line connecting those 2 points as carefully as possible. And so there we've graphed our line. We calculated the x and y intercepts by setting x equal to 0, solving for y, y equal to 0, solving for x. We plotted those 2 points and we used a ruler to draw a straight line through them. Alright then, we'll pause here and we'll go on to some more examples. Okay, let's go ahead and look at this one then. We have the equation negative x plus 12y is equal to 24. So the first thing that I want to do is let x equal 0. I could start with y equals 0, it doesn't matter. When I do that, when x is equal to 0, the x term is going to go away because 8 times 0 is 0, and I'm left with the equation 12y equals 24. And 12 times what is 24? 12 times 2 is 24. So we have the point x is 0, y is 2. And I can graph that. X is 0, y is 2. Next, I let y equal 0. And when I let y equal 0, I get negative 8x equals 24. And negative 8 times what is 24? Since 24 is positive, I need a negative times a negative to get a positive. So x would be equal to negative 3. And so I would have the ordered pair x is negative 3, y is 0. And so now I can go to x is negative 3, y is 0, plot a point, and draw my line as carefully through them as possible. And so now I have a line. I've calculated the x and y intercepts, or the y and the x intercepts. Then I've plotted those points and used those points to graph the line. Okay, so that's the first one. So let's go on to the second one. We have the equation 2x plus y is equal to 4. So the first thing I want to do, let x equal 0. When x is 0, 2 times 0 is 0, and I have the equation y is equal to 4, or my y value is 4, and so I have x is 0, y is 4. Now it's important to note that this y equals 4 is different than the y equals 4 equations that we were graphing before. This is a specific value. When x is equal to 0, we know that the y coordinate that goes with that x has to equal 4, and that's what that means. Next, we're going to let y equal 0. And when y is 0, we have the equation 2x is equal to 4. And 2 times what is 4? 2 times 2 is 4. So we have the equation 2, 0. So we're going to graph these 2 points. X is 0, y is 4. X is 2, y is 0. And draw our line through those 2 points. And so we've graphed the line there. All right, so that should be it for this. And so this accomplishes the second learning goal in this section, and that is to use intercepts to graph a linear equation, to calculate the x and y intercepts, or the y and the x intercepts, and then to use those intercepts to graph a linear equation. Very good. So we'll stop this video